Hi ma'am, this is my video presentation in activity number 5. Question number 1. Given are the different Clipper circuit diagrams. Create a video presentation explaining how the output waveform can be generated. Assume that the input waveform is a sinusoidal with a peak value of Bm. Letter A, series Clipper. In letter A, you need to draw a circuit diagram in figure number 1. And figure number 2 is you need to draw a input waveform, and lastly a output. You can draw output waveform. Wherein figure number 1 shows series negative clippers with positive bias voltage connected in series. When V input is equal to 0, diode will be forward bias till VIN reaches 1V. Output voltage will be 1VN. When V input is greater than 1V, then V output is equal to V input plus 1V, as shown in figure number 2. During the negative cycle, diode will be reverse bias, hence output voltage will be 0. In letter B, bias series clipper. Positive cycle of the input. When the input voltage is applied, the positive cycle of the input makes the point A in the circuit positive with respect to the point B. This makes the diode reverse bias, and hence it behaves like an open switch. Thus the voltage across the load resistor becomes 0 as no current flows through it, hence V output will be 0. Negative cycle of the input. The negative cycle of the input makes the point A in the circuit negative with respect to the point B. This makes the diode forward bias, and hence it conducts like a closed switch. Thus the voltage across the load resistor will be equal to the applied input voltage as it completely appears at the output V output. And you need to draw a waveform. If the waveform are observed, we can understand that only a portion of the positive peak was a clip. This is because of the voltage across VO, a V0. But the ideal output was not meant to be so. Let us have a look at the following figures. In sinusoidal, VM is reached positive and negative VM in the negative side. Letter C, parallel clipper. As in figure letter C, positive terminal of the battery is connected to the cathode of the diode. This causes the diode to be reverse biased at all times, except when the input signal is more positive, the bias voltage VI is greater than VB. It will be interesting to know that if the polarity of the bias voltage is reversed, the resulting circuit will be as shown in figure letter C. Here the input signal lying above the voltage VB is clipped. The waveform of the output voltage are also shown in figure letter C. Negative clipper was allowed to pass the positive half of the input voltage and clip the negative side half cycle completely. Figure the shown parallel negative clipper. In sinusoidal, the positive V is going to the right and the negative V is going to the right also. It gains the positive value of Vm is going to right, and the sinusoidal value of negative side is going to right. In such a circuit clipping take place during the negative half cycle only when the input voltage Vi is less than Vb. The clip level can be shifted up or down by varying the bias voltage Vb. It will interesting to know that if the polarity of the bias voltage is reversed, then the resulting circuits will be shown in figure letter C. Here the entire signal below voltage has been clipped off. Letter D. A parallel bias clipper is a circuit that clips the positive and negative going to portion of the input signal simultaneously. Number 2. Given are the different Clampers circuit diagrams. Create a video explaining how the output waveform can be generated. Assume that the input waveform is a square wave with a peak value of Vm. A positive bias voltage clamp is identical to an equivalent unbiased clamp, but with the output voltage offset by the bias amount of V bias, thus V out is equal to V in plus V input peak plus V bias. In the negative bias, a negative bias voltage clamp is likewise identical to an equivalent unbiased clamp, but with the output voltage offset in the negative direction by the bias amount V bias, thus V out is equal to V input minus V input peak plus V bias. That's all, ma'am. Thank you po.